You know, your smart speaker is always listening. Your thermostat, it's learning your habits. Your car, connected. And even critical things like an insulin pump depend on these digital links. We really lean on this stuff daily, maybe without even thinking about it.
Absolutely.
But what happens when those connections, those things that make life easier, actually become, well, vulnerabilities? Welcome to the deep dive. Today, we're diving headfirst into the fascinating and maybe a little bit alarming world of practical IoT hacking.
It's definitely a hot topic.
Yeah, and we're drawing our insights from a really definitive guide on this. It's a book that pulls together the real-world methods and actual exploits found by 5 top IoT security researchers.
Real practitioners.
Exactly. So our mission today is to sort of unpack the common threats, some surprising ways things get hacked, and how these everyday devices can be compromised. Basically, giving you a focused look to understand the digital side of the Internet of Things.
And the thing is, this connected tech landscape, it's just exploding, growing so fast, often way faster than our ability to actually secure it all.
Right.
So this dive really gives you a practical roadmap, to understand the risks straight from the folks who are actually testing these systems.
Seeing it through their eyes.
Yeah, seeing it like a hacker would, not to scare people necessarily, but more to build awareness and hopefully informed action.
The personal stakes when IoT vulnerabilities hit home.
Okay, let's unpack this a bit more. Before we really get into the technical side of hacking, let's talk about why this matters. Why isn't it just some abstract tech issue? It feels really personal.
Oh, it is.
I mean, we're not just talking smart light bulbs here. These are devices deep inside our lives, sometimes literally keeping people alive.
Yeah, that intersection of convenience and critical safety is fascinating, especially with medical devices. Think about Jay Radcliffe. He is a security researcher, but he's also a type I diabetic. Back in 2016, he found 3 pretty serious security flaws in his own insulin pump. The Anima's one-touch ping.
Wow, his own device.
Exactly. And this wasn't just a quick look. He spent months setting up a test lab, even got legal advice to make sure he was doing everything by the book before he reported it.
That's incredibly personal. He's literally testing the security of the thing keeping him alive.
Yeah.
But, from the manufacturer side, isn't there an argument that telling the world about these flaws could actually make things more dangerous short term, giving bad actors ideas?
That's the tough spot they're in.
How do they square that fear with, long-term patient safety?
That really is the core dilemma. And Marie Moe, another researcher who relies on medical devices, she talks about this really well. Manufacturers face these incredibly hard trade-offs. I mean, think about a pacemaker or a spinal stimulator. They have unique constraints, right? Tiny size, limited battery power, has to be super reliable.
Yeah, you can't just put standard computer security on that.
Exactly. Applying conventional IT security is really challenging, so maybe they use proprietary software hoping nobody finds the flaws, security by obscurity, basically.
Right.
Or they take older tech and just add connectivity to it, which suddenly opens up way more ways to attack it.
Increases the attack surface.
Precisely. And all of that directly impacts patient safety. So the big question is, how do we genuinely manage both life-saving function and solid security without cutting corners on either?
It really just drives home that these aren't abstract tech problems at all. They have real, direct human consequences. The stakes just couldn't be higher.
The hacker's playbook, common entry points, and clever exploits.
Okay, so let's switch gears. Put ourselves in the shoes of a security researcher. If you're hunting for weaknesses in, say, an IoT system, where do you even start?
Well, usually you want a structured approach. We often use threat modeling frameworks, something like STRIDE.
STRIDE?
Yeah, it's an acronym. Stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. It just helps you categorize and think through potential threats across the whole system. The device itself, the network, the cloud part. Make sure you're looking everywhere.
All right, let's bring it home a bit. Think about your smart home setup.
Right.
What are some ways, maybe surprising ways, these things we use every day can be, hacked? I mean, it's not always going to be some super complex cyber attack, right?
Yeah, absolutely not. Often, the simplest tricks are the ones people miss.
Like what?
Well, take a smart door lock, a classic example.
Okay.
So the way it usually works is your phone talks to a server in the cloud, right? Manages who gets access.
Mm-hmm.
Now, let's say you give a friend or maybe a guest temporary access, a digital key.
Yeah.
What if that guest, maybe not so friendly, just turns their phone onto airplane mode after they get the key or lock? It never gets the message later when you try to revoke their access.
So they can still get in.
Exactly. They still have access to your place. It's like a super low-tech way around a high-tech lock. Just shows how simple user actions can create vulnerabilities.
No, yeah. Simple but effective. That's a real aha moment. It's not always about cracking code, but that one relies on what the user does.
Mm-hmm.
What about flaws in how devices just talk to each other on your home network?
Right. That really gets at how making things easy for users can sometimes make them insecure.
Mm-hmm.
A key thing is that lots of IoT devices, because they want to be super easy to set up, use what are called zero configuration protocols.
Zero config, like plug and play.
Exactly. Universal plug and play, UPnP, or things like multicast DNS, MDNS, Web Services Dynamic Discovery, WS Discovery. They prioritize automation, making things just work.
Okay.
But they often operate on a dangerous assumption that everything on your local network can be trusted.
And that's where attackers get in.
That's the opening. There's a really long history of UPnP bugs, like going back decades, led to all sorts of problems, from buffer overflows to attackers creating hidden proxy networks using something called NAT injection.
So this constant tension, convenience versus security, that often ends up being the biggest vulnerability in IoT.
Very often, yes. Take WS Discovery, for example. An attacker can use it to sort of fake being an IP camera on your network.
Fake a camera? How?
Well, imagine your video recorder is scanning the network, looking for cameras to connect to.
Okay.
The attacker sends back a probe match response, basically yelling, "Here I am," before the real camera does.
Oh, so it tricks the recorder.
Yeah, it tricks a recorder into thinking the attacker's fake device is the real camera.
Yeah.
Then they could feed it fake video or maybe completely take the place of a real camera that happens to be offline.
Wow.
These protocols, built for seamless connection, they just create huge opportunities if security wasn't baked in from the start. It's like leaving your back door unlocked, assuming only friends will drop by.
The deep hardware and firmware layers.
All right, let's go deeper. What about the actual, guts of these devices, the firmware, the hardware chips? That feels like where the really sensitive stuff might be hidden.
Oh, absolutely. That's often where the crown jewels are, so to speak. Firmware, especially.
Firmware. That's a low-level software, right?
Exactly. It's that software etched right into the device's memory, the bridge between the physical hardware and the main software. It's a gold mine for information and potential weak spots.
And how do researchers even get that firmware?
Well, sometimes it's easy. Vendors often put it on their support websites for updates or troubleshooting.
Okay.
Other times, it's harder. You might have to physically open the device and use special tools to read it directly from the memory chips.
And once they have it, what kind of things are they looking for? What are the common, maybe surprising finds?
Hard-coded credentials are incredibly common still.
You mean like passwords just written into the code?
Yeah, or stored in configuration files. For instance, if you look at the file system of, say, a popular Wi-Fi router like the Netgear D6000, you might find default logins like admin.
Wow.
Or even simpler ones like 1234 in files maybe named romfile.cfg, and tools like Hashcat. They can crack those weak passwords in like under a minute sometimes.
That's just basic security hygiene failing, right?
It is, and it's a huge wake-up call for anyone out there who's never changed the default password on their router.
Definitely a critical point. But okay, what about even deeper, like physical access? If someone actually gets their hands on the device itself.
Yeah, physical access is often considered game over. In security terms.
Game over.
Pretty much. See, devices often have these debug ports, UART, JTAG, SWD. They're meant for developers for testing and programming the chip during manufacturing.
Right.
But they can often give you really low-level access, sometimes even root access, to the device's core system.
So you can basically take control.
Potentially, yes. Now, some designers do try to make it harder. We've seen, for example, medical devices with physical fail-safes, like actual fuses designed to blow and destroy the circuit board if someone tries to disassemble it carelessly.
So they are thinking about tampering.
They are, which shows it's a serious concern. But even those protections can sometimes be bypassed by a determined attacker. The physical layer is just a major vulnerability point, because once you can physically interact with it, the possibilities really open up.
The invisible waves, radio, and wireless exploits.
Okay, so many IoT devices, they don't use wires, right? They communicate wirelessly. What about the risks there in the air all around us?
Right, the radio waves. Medium-range protocols like Wi-Fi, that's a huge attack surface. Huge.
Hmm.
You're talking things like denial of service attacks, just knocking all your devices off the network. Or attacks like known beacons.
Known beacons, what's that?
That's where an attacker tricks your phone or laptop into automatically connecting to their fake Wi-Fi hotspot because your device recognizes the network name from somewhere you've connected before. Oh, clever.
Yeah, and even your standard router security, like WPA2, isn't foolproof. There are ways to attack weak implementations or try to brute force something called the PMKAD,
PMKD.
Pairwise Master Key Identifier. It's used to help devices roam faster between access points. But if that system, it's called 802.1RR, is enabled, it can sometimes be targeted.
So wait, an attacker could just set up a fake network named like coffee shop Wi-Fi,
Exactly.
and my phone might just connect automatically if I've used a network with that name before.
That's the core idea, yeah.
Yeah,
And once your device connects to their fake network, they're sitting in the middle.
a man in the middle.
Right, they can potentially see your traffic, maybe even mess with it. And it's not just Wi-Fi. Think about short-range radio like RFID.
Oh yeah, key cards, transit passive.
Exactly. It's totally possible to clone those cards. You need specialized tools, something like a Proxmark 3. It's a well-known tool for RFID research.
Okay.
Once you manage to get just one key for one sector of the card's memory, you can often run what's called a nested authentication attack. Sounds complex.
It basically uses that first key to help you figure out all the other keys. And once you have those, you can read, and sometimes even write, to the card's memory.
So you could clone your building entry card, or maybe even add money to a transit pass.
Potentially, yeah.
Yeah.
Cloning an entry card is a classic example. And for something like a transit card, if the permissions, the access bits on the card are set up incorrectly, you might be able to write data, like adding value, using just one key you found.
Wow. Okay, so RFID is vulnerable. What about Bluetooth? Like for my smartwatch or fitness tracker?
Good question. Bluetooth Low Energy, or BLE, that's what most wearables use.
Yeah.
Smart water bottles, watches, fitness trackers.
Right.
Attackers can often scan for these devices and figure out what kind of data they transmit, battery level, sensor readings, settings. These are called characteristics. And then depending on the security setup, they might be able to read that data or even write new data back to the device to change how it works, especially if the device isn't using a secure, authenticated connection.
So even my water bottle isn't safe.
Well, the risk depends on the device. But yeah, the convenience of BLE often comes with potential security trade-offs if it's not implemented carefully.
Navigating the IoT landscape, ethics and solutions.
Okay, hearing all this, it can feel a little overwhelming, honestly. It really shows how many vulnerabilities are out there, how much trust we're placing in all this tech.
That's a lot to take in for sure.
So what's the way forward then? How do we actually make this stuff safer?
Well, connecting it back to the bigger picture, it really highlights why coordinated vulnerability disclosure is so important.
Coordinated disclosure? You mean researchers working with the companies?
Exactly.
Oh.
It's the process where researchers find a flaw, but they responsibly report it to the manufacturer first, giving them time to fix it before it's announced publicly.
Okay.
Remember Jay Radcliffe and his insulin pump?
Yeah.
He went through the manufacturer's official reporting process, laid out all the technical details, explained the potential impact, suggested ways to fix it, and that collaboration, even though it took months, it meant the problems were fixed and patient safety was prioritized before the wider world knew about the specific vulnerabilities.
Right, so it's not about like dropping 0 days to cause chaos. It's about partnership to make things safer, recognizing that just ignoring a problem doesn't help anyone.
Exactly right. The path forward really has to involve more transparency, better collaboration, and frankly, more understanding and empathy between the researchers finding flaws, the companies building the devices, and us, the users. It's crucial to accept that cybersecurity issues can become patient safety issues or physical safety issues, and just keeping quiet about known problems. That doesn't make anyone safer. We all need critical thinking, especially with so much information out there. Users like you should feel empowered to question assumptions. Consider different views about how secure your devices really are. And the good news is, the legal side of things around owning your device, being allowed to do security research on things you own, that's slowly getting better. Thanks to a lot of effort from hackers, academics, companies, even informed people in government, all pushing for a more secure, more open approach.
There we have it. We've journeyed through the complex, sometimes, yeah, a bit scary, but definitely fascinating world of IoT hacking.
Hmm.
From critical medical devices and smart locks down into hidden firmware secrets and out to the invisible radio waves of Wi-Fi and RFID.
We covered a lot of ground.
We really did. We've seen how that drive for convenience can sometimes unintentionally create these vulnerabilities, and also how dedicated researchers are out there working hard to find and help fix these flaws.
Our reliance on all this connected tech, it's just growing so much faster than our collective ability to truly secure it. It creates this constant tension in our digital lives.
Yeah.
And that really raises a big question for you listening right now. As these devices weave even deeper into our homes, our health, our cities, how do you personally square the undeniable convenience they offer with this inherent, often surprising lack of trustworthiness?
That's the key question.
And maybe what steps can you take, whether it's advocating for better security or just being more aware yourself, contributing somehow to a more secure future? Because these technologies, the ones meant to make life easier, they're driving our cars, delivering healthcare, watching our homes now. It's a powerful reminder that being vigilant, being aware in this digital world, it's more critical than it's ever been.